Good morning, good afternoon, good evening. I would like to welcome you all to the C2GDiscuss event addressing marine-based climate-altering approaches. Just a few words on C2G, the Carnegie Climate Governance Initiative. It's a philanthropically funded, time-limited initiative, and our focus is to contribute to the effective governance of emerging climate-altering techniques such as large-scale carbon dioxide removal and solar radiation modification. We're impartial about their use or not, and that's an important component of our work, and we work catalytically. Now, the aim of the C2GDiscuss series is to engage in conversations on tough issues that are faced by decision makers, in particular to address key issues on governance, such as who should be involved in the discussions, what are the impacts on sustainable development, on ethics, on justice, how policymakers assess the risks of these techniques versus the risks of a warming world and versus the risk of not doing them. So there are many perspectives, and we look forward to hearing as many perspectives as we can. It's also important to note as we get into the discussion that there are considerable materials on these issues on the C2G website, lots of knowledge products that are in document form. We also have the so-called C2G Learn series that are essentially webinars and question discussion sessions about various topics which you may want to look at, and also the C2G Talk, which are interviews with specific experts on specific topics. So today we have three excellent experts with us, and I would like to ask them to introduce yourselves, so maybe half a minute each, who you are, what is of interest for you. Please go ahead. So let's start with Joyashree.
Hi, this is Joyashree from Asian Institute of Technology in Thailand, and also Jadavpur University in Kolkata in India. I'm trained first as an economist and then as an environmental economist. One of my research focuses is to understand how human actions in response to climate change can be more synergistic to multiple dimensions of human well-being and sustainable development. And I was involved in the high-level panel on ocean report and also with 1.5 special report of IPCC.
Thank you very much. Kristina, may I ask you to continue?
Hello, thank you. Kristina Maria Gjerde. I'm Senior High Seas Advisor to IUCN, the International Union for Conservation of Nature, their Global Marine and Polar Program. I first encountered climate engineering back in 2007 when the first proposals were being made for sprinkling iron dust into the ocean. And I was contacted by a colleague from Woods Hole Oceanographic Institute, a leading deep sea ecologist, who said it's amazing how much damage they can do for so little money. I've been involved largely in trying to fill the black holes of ocean space in ocean law. That's trying to meld science, policy, and international law of the sea and international environmental law for the past 20 plus years, largely with IUCN. I'll leave it there. Thanks.
Thank you. And Stefanos?
Good afternoon, Joel. Thank you, Janos. My name is Stefanos Fotiou. I work for the United Nations Economic and Social Commission for Asia Pacific. It's called UN-ESCAP. And there I'm the director of the Environment and Development Division. And part of the division's work is also to coordinate ESCAP's response to climate action. And our main focus there is to support our member states and especially developing and least developed countries on raising their ambition of their nationally determined contributions to the Paris Agreement and try to do this by developing a nexus of action between climate action and biodiversity action. We do believe that the biodiversity emergency and the climate emergency are two faces of the same coin, which is the coin of unsustainable development patterns, and we try to see them holistically. So we try to support solutions and especially support policy actions that at the same time, they will have a big mitigation potential and they will not only harm biodiversity, but hopefully they will even improve biodiversity. and I'm looking forward to the discussion. Thank you, Jan.
Thank you very much. And I also look forward to the discussion. And before starting that, maybe I just share a few thoughts about the context in which we're having this discussion. So first, I think it's fair to say that the climate crisis continues. And in spite of very positive commitments by many countries and even non-state actors for net zero emission commitments by mid-century, the world basically continues to underdo what is needed for the 1.5 to 2 degree goal. And therefore, it's clear that the number one priority must be emission reductions, and that's the baseline. But then there are maybe other things that we also have to do, and there comes the ocean. And the ocean is, of course, the great regulator of climate with the water cycle, the oceanic circulation, the oceanic biological pump. It absorbs a quarter of annual carbon dioxide emissions. It absorbed 90% of excess heat caused by anthropogenic greenhouse gases. And the list can go on, but there are limits. What the ocean gives, it can also take away, and especially if not managed properly. We can look at the acidity levels of the ocean, the oxygen levels, the warming of surface layers, the circulation changes, and so on. So it's in that context, and the fact that the climate situation continues to be challenging, that many are looking at the ocean as an option area for large-scale carbon dioxide removal, also for solar radiation modification. It appears that in terms of carbon sequestration, the ocean could provide literally gigatons of potential annually. And maybe in some cases, depending on the technique used, could also have a positive impact on the acidity levels. And then there is solar radiation modification, where stratospheric aerosol injection could provide global benefit, and marine cloud brightening could provide regional local benefit in terms of cooling the area concerned. And that, of course, would have large potential benefits, but also risks and governance challenges, some potentially quite substantial. So in order to address these, we need to have conversations about the risks and the governance challenges, and of course the opportunities that may arise. And we need to do that now, because things are changing very fast. The 84% of the ocean, I'm told, has experienced at least one mega heat wave in 2020, and presumably more to follow. And experiments in these new methods are taking place. For example, in Australia, the marine cloud brightening experiments, and some other experiments, Kristina already referred to that earlier, and others will surely take place later. So the time has come to address these issues. So with that, let's move into the panel discussion. And what I would like to do now is I will ask each panelist an initial warm-up question. You can spend maybe 3 minutes to address those questions, and then we'll get into a discussion. And what I hope is that the panelists will ask each other some questions, maybe follow up on some of the issues that they have heard. And I also have a few questions at the back of my pocket in case things slow down. But I definitely look forward to an interesting discussion. So let's start, and maybe I would like to ask Joyashree first, if I may, if you could help us to look at how various interventions in the ocean system are linked with sustainable development.
You know, I would start with a little bit background of the Sustainable Development Goals, 17 goals, which were undertaken in 2015, because this marks the global governance strategy for sustainable development till 2030. And this expresses the best, the common desirable future for humanity. So action to fight climate change has to be viewed through the lens of its contribution to broader societal objectives, and thus to be aligned with other sustainable development goals in the near term, but also with broader sustainable development dimensions in the longer run. When it comes to relatively novel mitigation approaches, experience regarding potential co-benefits and negative impacts is limited. Good and bad, both may arise directly and indirectly because of its insufficiently understood operational level of outcomes. We did an assessment for energy sector and the land sector in the IPCC's 1.5 degrees Celsius report, but could not do that for ocean due to limited knowledge that was available at that point of time. So it is therefore very difficult to make an informed choices and decisions that mobilize the CDR or SRM in a way that supports rather than undermines sustainable development overall. So ocean-based mitigation options to reduce or sequester and store emissions have significant potential to contribute to the global efforts to limit global warming and for achieving the goals of Paris Agreement. However, what we need to understand is also that both the ocean and land-based sink capacity is also very high, and which we have come up in our critical junctions report on the journey to 1.5 degrees Celsius from climate strategies. And we show that there is a number of decisions that we need to take in this decisive decade to make this to make the future more sustainable. And along with that, the sink capacity has to be ramped up. But what really matters is that although there is untapped mitigation potential as carbon sink in the ocean, but we need to understand what are their implications for the sustainable development. In our high-level panel report from WRI, what we could come up with is that there are 5 ocean-based climate actions: ocean-based renewable energy, ocean-based transport, coastal and marine ecosystem, ocean-based food system, and carbon storage in the seabed. But what happened was that we could see that all these have high mitigation potential, and they can help in actually bridging the gap in the emission by 2030, say by 12%, if all these are done up to a particular level, which we show in the report. And that can be actually up to 20% by 2050. However, what we could find is that the sink capacity of oceans, only for carbon storage in the seabed, we could make an assessment for the sustainable development goals and for sustainable development dimensions. But for all other actions, say, for example, the ocean fertilization, injection of CO2 in the deep ocean, and all those carbonate dissolution. So all these things which we could not do because of lack of enough evidences and enough research. So I will stop very soon by saying this, the initial remark that for ocean system, there is a high potential for mitigation, but there is really a lack of substantial research which is necessary for any particular intervention to go forward. So there is, because the existing research shows both the good and bad sides. So it is not yet understood that how far this will impact the environment. So more concerns are about not about the climate mitigation potential, but about the societal and environmental impact and the marine biodiversity impact. So I'll stop here now, but then I'll come back to this later in the whole discussion.
Thank you very much. And indeed, you raised a couple of important issues that we will have to come back. In particular, some of the gaps in knowledge and what that implies for research work, et cetera, in the future, and also looking at the potential both for sequestration, but also for mitigation and other sustainable development objectives. So thank you. And Kristina, can I continue and maybe ask you something more on the legal side? What impact could the new legal instrument that is being negotiated under UNCLOS have on the ocean-based carbon dioxide removal or solar radiation modification and their research. This is something quite recent and it's probably important, so please.
Well, thank you. So I should first say that this new agreement for the conservation and sustainable use of marine biodiversity beyond national jurisdiction originated from this need to fill the gaps, to fill and support some of the weaknesses in international law. Deep sea bottom trawling was an example where the RFMOs weren't regulating, but this ocean iron fertilization proposal was also a keen example where you had to really scramble to find some framework that it might fit under. And that was through, this deep search of the London Convention and the discussion of dumping or placement that is liable to cause pollution. What we revealed then is sometimes the engineers go in without a full array of knowledge of ecosystems, of the biodiversity that is in these places and the interaction, and that they could in fact create more nitrous oxide and methane through the decomposition of the phytoplankton than they were actually sequestering down below. So my approach has always been, let's make sure we do not do more harm than good. And that requires an intricate understanding of the complexities of the marine environment, not just the marine biodiversity, but also the ecosystems of which they're a part. So then at the same time, governments at the United Nations started talking about this new international legally binding agreement. Well, they finally agreed that we will go forward with this in 2015. And that is primarily based on 4 components. And this is marine protected areas and other types of area-based management tools, environmental impact assessments, capacity building and technology transfer, and the benefit sharing of marine genetic resources. So we've been in negotiations, now official negotiations for 2.5 years, 3 sessions. The 4th and hopefully final session is scheduled for August of this year, but looking increasingly bleak as the United Nations has just postponed a review of the Fish Stocks Agreement conference. But that said, we are hoping that this 4th meeting, when it happens, hopefully in early 2022, will be the final meeting where governments come together to craft and agree upon a high ambition agreement, because we don't have times to wait. What the agreement can do for carbon is marine protected areas as really the best nature-based solution to safeguard biodiversity and resilience and enable species to adapt to change. Also to store carbon, we have kelp beds, sargassum weed in the middle of the high seas. Sometimes too much and sometimes not enough. But most importantly, probably, is the environmental impact assessment provisions that are currently being negotiated. There are less strong ones and more robust ones currently on the table. The idea and the hope is that the environmental impact assessment provisions will get to these new technologies before they're actually implemented and require a showing of potential range of impacts. And in the strongest version, actually making sure that there's sufficient information to make this informed decision that you're not going to be causing significant adverse impacts. And if so, then you don't manage it to proceed, the same basis that we're now regulating deep sea bottom fishing. Environmental impact assessments are commonly used for site-specific assessments of the potential impacts and alternatives. What the treaty also has potential to create are platforms for strategic environmental assessments, which would actually encourage, I won't say force, coordinated research and understanding of a particular technology or a new activity. And this is where I really see as the important role of the new treaty, combined with the UN Decade of Ocean Science, is let's start understanding the ocean biological pump, the vast role of the ocean twilight zone between 100 meters and 1,000 meters that is actively working already to sequester vast amounts of carbon. But these are based on fish. If we start hoovering up these fish, the mesopelagic, what implications will that be? So the environmental impact assessments need to look at proposed activities for their impacts on the ocean climate system, and then also to make sure that these new technologies that are being proposed are fully studied, understood, and that the public is fully, transparently, and inclusively consulted. So those are really the three key points of precaution, humility, and research to make sure that we have enough knowledge to make informed decisions. Thank you.
Thank you, Kristina. And again, you know, it's many important issues. You've also raised the question of research. Also, what kind of research, directed with a goal or not, and but I think the most important message I got from you is this business about the linkages, not just to try to encourage the positive linkages and try to avoid hurting and creating problems when we solve issues in one sector, not just within the ocean, but also beyond the marine environment. So with that, let's move on to Stefanos, and maybe if you could just say a few words, Stefanos, on how you see the difference, or how you see the, on the one hand, ocean conservation, and on the other hand, climate action. Are these different? Are these opposing? Are they helping each other? Can you help us with some of your thoughts?
Thanks, Janos. I mean, I would say at the level of system thinking, whatever is going to alter the climate is going to alter the ocean, and vice versa. Whatever will alter the ocean will alter the climate. And I think that there's such a systemic relation there with many links that, and we don't know all of these links. So do we try to increase the ocean's capacity to absorb CO2? Yes, there's going to be some impact on climate, but then what's going to be the impact on the marine biodiversity? And I think that when we are looking at measures and at mitigation actions, that they will have a long-lasting effect, because whatever we will do now, it will have an effect on the next 20, 30, or 40, or 50 years. We need, and I will go to what Kristina said as first point, the precautionary approach. I mean, it's as old as the Rio, 1992, and I would say we need a kind of enhanced version of the precautionary approach, because who would have thought back in the beginning of the 20th century that the Haber-Bosch process of nitrogen would have created today one of the biggest environmental problems, the nitrogen pollution. I mean, when it started, everything was like we found the holy grail of feeding people and at the same time making it cost effective. So it was a cost effective method that it was feeding people, and it was responsible for the greening of agriculture. We see what happened in less than 100 years. The European Union, I think it has a study now saying that at least 1/4 of the nitrogen that has been processed through these processes needs to be removed from the cycle if we want to be sustainable. So I think we need the similar kind of thinking when it comes to the interface between ocean and climate. And I think we need, I would say, we need to start from, first of all, what are the classic mitigation options offering to us? How much we can really achieve with what we do say for the last decades: green energy, nature conservation, electrification, at the same time electrification and green energy, and putting a carbon tax, taking the fossil fuel subsidies off the table. So is this enough? And if it's not enough, how much we will need to add from various other methods? And you know, when we start talking about how much we need to add, we are talking about nuclears, we are talking about probably solar radiation removal, we are talking about modification, we are talking about the CTR. And then we need to see, I think we need to resolve first all the scientific uncertainties when it comes to the impact on the ocean. We have impacted the ocean a lot so far with the plastic waste, with the overfishing, and we don't need to add another burden to the ocean. And there are different methods that they are discussed about, you know, the ocean-based carbon dioxide removal, from iron fertilization, which is extremely divisible and extremely sensitive, to alkalinity enhancement, which seems to be something that the scientific world says, okay, we might do it. So we need to put some clear scientific responses. Probably we need to talk only about a very small handful of methods to use when it comes to the ocean. And I would say, and I know that the mitigation potential is not very big, but when it comes to the conservation of coastal and marine environment, when it comes, for example, the conservation of the marine environment, of the coastal environment, we need to see how much we can achieve there, because the co-benefits there would be much larger. The co-benefits for employment, for erosion, the co-benefits for biodiversity. So I think I will leave it here.
Thank you very much. So first, I just want to ask if any of you would like to follow up on any particular point that were raised in the three initial. I see Joyashree, please go ahead.
Yeah, so what I was just thinking is that, you know, when we talk of the ocean, of the marine, mitigation and the sequestration potential, we should think that the coast and the ocean, two as different ones. And so if we see now, at least, you know, there are literature and proven experiments also, which shows that the coastal restoration of coastal ecosystem, like, you know, preservation of mangrove environment, tidal marshes, seagrass meadows, all these have high sequestration, carbon capture potential. And so it also builds resilience. So I think we know the safer grounds which we can work on, and they have also very high sustainable development potential, the linkage, also the co-benefits, right? But also what is happening is that there is a huge momentum which is growing up about the ocean system. So there is very important that we should not brush these discussions under the carpet. You know, there lies the danger, so that, you know, you get unintended impacts due to uninformed or less discussed intervention. So I really feel that it is better to discuss it over, bring it on the table and discuss, debate, and maybe we just need to do it every day, you know, so that we make the information and the dissemination faster, so that people get more involved. So, and from that point of view, what we actually in the ocean report also, what we could not do is only we looked into the CO2 storage in the ocean bed, right? But then for all others, like as you have said, over the fertilization and the alkalinization and all other interventions, we could see that the literature is so divided. There is no agreement among the scientists. So if there is less of agreement among the serious scientists, we need to give due recognition to these, and maybe more research can be funded for carrying forward those research to understand and to give us more knowledge. So as you all have said, precautionary principle, but we can extend the boundary of precautionary principle, and we can see that what are the new things with the new knowledge can come in, and how we can expand the whole portfolio. But I think we really need to be careful. But one interesting point which we came up with, I would just share with you this, that if we take this just one intervention of storing carbon in the seabed and not all others, and all the coastal interventions, then we could see that it's 11 billion tons per annum till 2050 we can mitigate from the ocean system, and which shows that this leads to reduction of a magnitude larger than the emission from all coal-fired plants worldwide, and then and more than China's total emission in 2014. So that's why we need to be looking into this potential also, and need to make more scientific research, so that we can see that what can be done and what can be done later. So we can phase-wise, we can see that what can be done with the marine and ocean system, because ocean is already a big sink of carbon, no? So how we can really understand the science of it and then try to see, because ocean is also a vast resource, so rich resource, and least understood what is the dynamics of it. So I think there is a huge research potential. We should be really focusing on that. As I said, we need to talk every day.
Thank you. And before going on to Stefanos, if I may just do a follow-up question here quickly, because you said that, you said many important things, but you said at one point that the scientists are divided. And I was just wondering, is it really that the scientists are divided about the science, or is that the general society is divided about the interpretation of the scientific results? In other words, do we need more research or do we need more conversation? We may need both, but in order to reduce the divisions. So if you may have a quick answer to that.
Yeah, so in our report, actually, we show that where scientists are agreeing, scientists, right, where they're agreeing and where they have less knowledge and less understanding about the environment, because they know the technology, they understand the technology, and there may be one or two pilot technologies have been tried out, but its impact on environment, on marine biodiversity, and on the societal impact, because most of these activities will be happening also within the territorial ocean system also, you know, it's just not outside the territories. So the nations really need to understand what it would imply, because if there is acidification more, or if there is impact on the biodiversity more, then how the economy and the livelihood of people which are dependent on these will be impacted. That is also less understood. So science is also less known, and the discourse is almost, if you ask me, I would say that is almost negligible. The bigger society, keeping aside those who are oceanographers or the marine scientists or the thematic researchers, right? But for the general public, it's almost nil. You can consider that. But within the scientists also, they are not, there is more uncertainty. I would not say they do not know, but there is more uncertainty than what is known. So it is important. Scientists themselves, when we were doing the report, we saw that they are also not comfortable to come up with this conclusion that yes, all different kinds of technologies can be applied right now. Some people think that that can be researched more, and after 2050 they might be available. So there are actually the phase-wise that we need to discuss. Sorry for long answer.
Thank you. That's very helpful. Kristina, do you want to respond to this quickly? Because Stefanos already had his hand, but
I'll wait until Stefanos goes.
Yeah, okay, Stefanos, go ahead.
Thanks, colleagues. I want to reflect a little bit on the need for more science, but actually the need to pass these scientific messages to the policy community, because that's the ultimate objective. Yeah, we need the science to support evidence-based policymaking. And I want to be a little bit provocative here by saying in the beginning that, you know, myself, I'm the biggest advocate, a fan of the IPCC, the IPBS, the IRP. I've worked the last 2 years to establish in ASEAN, the ASEAN Resource Panel, and I think that these science policy interfaces are the right thing to do. And then I'm thinking what happened to the 1.5 degrees report when it ended up at the negotiation in the UNFCCC. And you have been there, probably many of you, you remember the science is not negotiable. And it felt like an embarrassment at one point to have a report from the brightest minds all over the world that it was negotiated in a policy context, if we will accept it or not, and if we will say that we not, or we not with appreciation and whatever. And my thinking here is, if we haven't, as a UN community, managed to pass the most clear scientific message, which is that we really need to focus on 1.5, not above this. And we have managed to make this a policy action item. How we are going to talk with policymakers about things that they are much more sensitive. And to add another level of, I would say, uncertainty here, when we talk about this ocean-related CDR, we are talking about, I assume, I don't know the numbers, but we're talking about very big investments. Probably not the alkaline enhancement, because it could become with commercial ships, but other methods, they need massive investments. And when massive investments start to be part of the picture, corporate interest starts to kick in. And they would say, okay, this is a business opportunity. And we have seen cases that a business opportunity could distort sometimes the science and policy debate, because the private interest, it creates a very nice story that I will create income, I will create GDP growth, I will create jobs. And the moment that this enters the debate between policymakers, and especially in the developing countries, all other things are going at the second kind of level. So my question, because I want to finish, Janos, with a question that we can address both I think Kristina and Joyashree. The first is, what kind of additional research we need? If there's one research item that we need on this issue, what this should be? And the second, are the current fora of the UNFCCC, of the high-level political forum, the existing fora, and the mechanisms like the science policy interfaces, the right ones that we have to use to pass the message to the policymakers, or we need to find another way? Thank you very much.
Thank you, Stefanos. And before going on to Kristina, I would appreciate if you could start answering at least your second question, because you come from one of these international organizations, you've been working with many of the other ones. And do we have the right fora, or even if we have the right fora, are these fora working together in ways that we can achieve what needs to be achieved, which is what you said at the beginning, ultimately get the scientific information to the policy people in ways that they can use them. So maybe you can start that, and then I'll look forward to other reactions to that as well.
So I think we have the right fora. We need to use them more smart. So I don't think we need to create new fora, Janos. I think that the UNFCCC process, the high-level political forum on sustainable development, to go at big global things, including the General Assembly, and then the regional forum on sustainable development are the right fora. For me, the question is how we put this in the agenda. And you know that in all these fora, the agenda is a member state-driven approach. So I think we need some champion countries that they will step in and they will say, this should be part of the agenda. Because you remember, Janos, we have given space and we have tried to do things in the Asia Pacific Forum on Sustainable Development with the work that you're doing in the C2G. But you have seen that always it's a side event, it's an associated event, it's a scientific dialogue. But we need to enter this into the official agenda of the forums. So I think that's that was something that we need to try to do more. And I'm trying to do is even this more, Janos. I mean, in the last Committee on Environment and Development we had in Asia Pacific, we did have a specific item on climate action, and we did mention there also these new technologies. So I think there's a need for some champion countries to find them and put them in the official agenda of the discussion. And hopefully this will raise a little bit the level of ambition from the science policy interface towards some actions that they will be, if you want, at then more coherent, because when something is going in the official agenda of a forum, then there's going to be a report, there's going to be a decision. Even if the debate will not be conclusive, there will be items of the debate that scientists could take forward and could then see how they adapt their research, how they adapt the way they work with policymakers.
Thank you. Kristina. Sorry
Well,
for
there's
the
a lot
long journey to get to you, but
well, many rich thoughts, and so I will try to weave some of these together. When getting ocean climate on the agenda at any of these meetings is indeed a challenge, but I think we also need to think about getting ocean scientists into national delegations, into not just the expert bodies who are advising these national governments, but develop national mechanisms to make sure that the voices of an array of scientists are heard, as well as those from civil society. I also am part of the Deep Ocean Stewardship Initiative. I'm on the executive committee there because I recognize the value of deep sea science in informing climate policy, biodiversity policy, mining policy. It's absolutely essential, and it's one of the areas of least knowledge. But the issue is that most of the national delegations, at least the United Nations, are from the legal community. And it was only my call out by a scientist who, as I said, Fred Grassley, that made me realize that we as a legal community, as the diplomatic community, need to make that effort to truly understand the implications. Because too often you see in fisheries management meetings also the science being left at the wayside for political convenience. So we need that diversity of science from not just the benthic ecologists, those who understand what's going to happen, but we also need the midwater column, we need the phytoplankton specialists, we need the zooplankton specialists. So we are arrogant if we think we can just simply answer this by one or two oceanographers. The platforms for bringing this to the table, the IPCC, IPBES have done a tremendous job, but again, they are limited in where they can go with this information now. With respect to many of the geoengineering exercises, the London Convention and London Protocol have this Annex 4 that's supposed to be addressing marine geoengineering, but it only has ocean fertilization on there now, and they're only just starting to consider how do you actually regulate research before it goes commercial. And as Stefanos said, when you start to get monetary interests in here, everybody is trying to be fast and furious with how quick can we get these technologies out the door. I would go back to the seabed carbon sequestration. Well, that was pushed through the London Convention as an exception to the London dumping, but where are the provisions for long-term monitoring, long-term verification, and checking the stability of these structures that they're actually pumping the carbon dioxide into? So before we start trying new technologies, we need to really make sure we have the capacity to monitor, verify, and adapt any type of mechanism that we take on board to try to sequester carbon. Because if it's not down there for a long term, it's going to come back and slap us in the face. Yeah, I would just say that back to the BB&J agreement at the UN, what we're trying to do there is really get effective processes for environmental impact assessment at the get-go. And I would suggest we really need something that is more on the strategic environmental assessment basis. And that there's currently a debate whether this new treaty should focus on activities only in the high seas or activities with the potential to impact the high seas. And I would suggest that we really need to get to the activities within national jurisdiction with the potential to affect the climate system, the ocean system, because with that can come capacity building, technology transfer, and more assistance, as well as accountability for what is going on. These are decisions that can't just be made at the national level, even if they're undertaken within national waters. Of course, beyond the coastal zone where you're working on carbon sequestration, the blue carbon stuff, but I'm talking about big major industrial type activities. Thanks.
Thank you, Kristina. And you've alluded to a number of important elements of what might be part of the research agenda, if there is such a thing. And I think you talked about the complexity of the different dimensions. And still, we only, I mean, so far, even in this discussion, we talk mostly about the 2 or 3 methods, but there are not 2 or 3, there are 10, 15, and there are very different ones. There is the idea of solar radiation modification, you know, stratospheric aerosol injection, marine cloud brightening, or many other carbon removal techniques as well. So I guess the question, and this is linked to what Stefanos also was his first question, is what kind of research, is how could we arrive at and who could arrive at a sort of a research plan of what the international scientific research community should research, and how that material should come to the policymakers. So maybe you could just have a few more thoughts on that, and I see Joyashree is also trying to react to that. So
well, I think Joyashree is in a good position to start out with that, having been part of the IPCC report, because I think you need many of those same people to start saying what are the research holes. There are already good indications in that report itself, but it needs to be sort of an internationally co-developed agenda of what are the big questions that we need to understand. And, you know, I would suggest, just like space research, we're a lot better off with international collaboration. This is an area where we all have a stake in the future of the planet. And, you know, let's find a way to collaborate with the Chinese, with the Russians, with those who are difficult, but to help use this necessity of science to really help build bridges and that mutual trust that it really underpins future collaboration.
Thank you.
Joyashree, please.
Now, what I would just suggest is that exactly what Kristina, you have said, that we need an international, that's why I said, let's not brush it under the carpet, let's bring it up on the table and let all of us discuss, right? So it might take 1 year, but 1 year is just nothing when we talk in terms of centuries for planning something, right? So that's something which I just think is very important. And second thing, what I just think is that in such matters, when we talk of technology readiness, I think we need to go beyond the standard technology readiness of TRL, you know, 1 to 9, and then tick mark those, so whether we have done that. But here we need maybe a TRL 10, you know, which really talks about how the global common resources are being, so we need to invent that. So for monitoring which technology should pass for commercialization under such circumstances, we need a separate one. Right now, all technology passes through TRL 1 to 9, right? Because that's the commercialization. But here, commercialization would mean something else, some bigger, just not the commercialization, but also societal and environmental impact. So we need to add one layer to that technology, which I just feel that in all the discussions, that is really coming up. And second thing, I'll just come back to what Stefanos said. One point, I'll touch upon that, and then I'll come back to this again, that actually I was always in the approval sessions for IPCC report because I have been the coordinating lead author. But if you ask me personally, I would say that science is not negotiated. What is negotiated is how you present the science so that it becomes understandable to people. So if you ask me, I would say that I would not take it as a negative thing. Rather, it's also has been mutually learning for both the parties. There has been a lot of understanding which have come up through these dialogues and debates, you know. So it's tough. I would not go by what news media talks about because they look for newsy things, right? But what I'm just saying is that really what really goes on is how do you communicate science so that it becomes understandable not only to scientists but to a common person. So that way I do not see it as a negative thing. And but now coming back to what research is needed, just a couple of things which I can say, right? Say, for example, as soon as they talk about CO2 putting it under the seabed, then still it is not known what is going to be the leakage. So leakage part is not well understood scientifically. Second, many people say that, okay, there can be some kind of barrier which can be built underneath, but that has not yet been tried out. So how that can be built and what would it mean for the ocean biodiversity, that is also less understood. So from those point of view, say for example, fertilization through nitrogen, it has already been said, but what does it mean for the long term on the marine ecosystem? That is also less understood. So I think, I mean, what is really important is that multiple researchers in multiple locations need to happen on same thematic areas so that you can compare the results and then you can come up. So simultaneously these need to come up. And then only you can come up with, it's not about one science and one particular experimentation. When we are trying to make it faster progress, then we really need a scale. The scale in experimentation also. It's just not scale of deployment, scale of experimentation also. Of course, there will be need for more money for all these. And so we need to think that if we have to, I mean, reduce uncertainty and live in a better informed world, then definitely we have to spend money on research. And so we have to find how this research money can come. And for that, many policy changes, etc., will be needed. So that itself is a research, no? So I think these are also needs to be talked about and needs to be discussed, and then we really need to come up with these. Just to give an example, how energy efficiency got the technology and its experiment got global scale, because, but it took long time, but we do not have that long time right now. Right now, the vaccine, how did it really became almost global in different parts? Because everybody put in effort, right? So I think we really need to think, this is high time. Pandemic has also shown us that what scale of actions are really needed for making things secure for human being.
Thank you. And we have only about 5 minutes left. So maybe I'd like to ask one round from one question, and please feel free to respond to any part of it. But Kristina, you mentioned at the beginning the word humility. And you know, the question arises, the challenges are huge, the ocean is huge, the problems are big, but still, can we do this? And should we do this? Should we pump billions of tons of carbon additional somewhere in the sea? Should we do clouds, create clouds above the Great Barrier Reef with artificial technology and thereby cool that area? And if we do these things, aren't we going to relax the pressure from what really has to be done quickly, which is to reduce our emissions? So are we in a bind here? Is this, how do you look at this? So maybe let's start with Kristina, and then Stefanos, and then Joyashree.
Well, I'd say perhaps while we're spending money for internationally collaborative research to understand basic ocean processes, it would be also useful to focus much more on ongoing activities and way to make these carbon neutral. I'm talking about shipping, where their current ambition of having emissions by 2050 is not in tune with the Paris Agreement commitments and really needs to be stepped up. Let's utilize the technologies we have and make sure that they're closed loop so they don't pollute more into the environment. Fisheries, let's stop overfishing. Let's stop paying fuel subsidies so that vessels can go out to the high seas and overfish. So we have a potential to drop those subsidies. That would probably get us a very long ways towards reducing CO2 consumption. Deep seabed mining is also on the agenda. Do we really need to start interfering with basic carbon biological pumps before we understand them? you start to bring up all the sediment into the midwater column, creating a haze where these creatures can no longer function. We need to have the science to create informed decision makings. Do we need to start pumping more oil and gas? Let's start with the simple things. Let's keep it in the ground. Let's stop. Let's take some radical measures to become carbon neutral by the end of 2030. At the same time, I'm a fan of marine scientific research. I'm also a techno-optimist, but I realize all the science fiction books that I read, if you don't take that humility with it, then things can go pear-shaped very quickly. So I think we need to learn the lessons of the future, ministry of the future, not start interfering with biological, ecological systems, but we need to understand before we go. But I think we have that capacity to start doing that research now, small scale experimentation, but precaution means we don't start launching these large scale manipulations. Thanks.
Thank you, Kristina. Stefanos.
Not many things to add with what Kristina has really very nicely said, but one point. We need additional research. We need to bring this into the agenda of global forums, but this, when it will happen, should not be used as an excuse to stop doing the things that they have been proved to work, to stop pushing for renewables, to stop pushing for a carbon price, to stop pushing for the complete abandonment and end to the fossil fuel subsidies. So I think that we need to pass this message. Yes, we need more research, but this is not research in order to substitute something that it has been proved that it's already working. And this is the mitigation measures that we are advocating for the last decades. Thank you.
Thank you, Stefanos. And this is really important. And maybe Joyashree, you can also address this of how to make this happen so that we don't end up in a kind of situation where doing the research gives excuse to others to stop emission reductions and so on.
Yeah, what I would say is that this is like a backstop technology, so that right now on the table, there are many options available, and all reports are showing that they can deliver and they can bridge the gap by 2030 and 2050 by deploying them, right? So as already said, even for ocean sector, renewable, ocean-based renewable, ocean-based transport sector, and then coastal and marine ecosystem, and then the ocean-based food system. So if we take all these four, there is still, we can do a lot. And then additional can come through carbon storage in seabed. And we really have less knowledge on that, so we can expand that knowledge. So I would say that we have enough on table to mitigate the gap and then mitigate the action. So there is no excuse which really says that why this can be beyond mid-century, we can be thinking of these actions. So, but then research has to start from today so that we are ready in next 20, 30 years.
Thank you very much. And this brings us to the end of this C2GDiscuss session. As you can hear and see, we've covered a very small part of a very big set of issues, but it also shows, as Joyashree said, at some point we need to discuss this every day. And yes, there are plenty of issues that hopefully will give rise to additional discussions in this and many other fora. So we hope that this session was a little bit of a contribution to that. So thank you very much. And together we can hopefully contribute to saving the climate crisis and the ocean at the same time. Thank you. Bye-bye.
Thank you.
Thank you.
you.
Thank you. Bye-bye.